bottle, and inside I have something which is actually called a Cartesian diver. Has anybody heard or seen a Cartesian diver? Okay. Well, one of the things that maybe we can do is we can get this diver to go down. Does anybody have any idea how I might do that? Yes?
Pour more water in.
If I put more water in? Most probably not. I tried it before and it didn't work. Yes?
Flip the bottle.
Flip the bottle. Okay, still wants to stay up. Any other ideas?
Take water out.
Sorry?
Take water out.
Take water out. Yeah, if I took water out, it would go to the bottom. I'm asking, with the amount of water that I have inside, is there a way that I could make it? Yes?
Twist the cap off.
Twist the top off.
Okay.
Well, I tell you what, maybe, since you seem like a very clever group of kids, maybe what we'll do is we're going to see if we can use brain power to make this diver go down. So what I'm going to do is I'm going to hold this above my head, and we're all going to focus and concentrate on the diver, and we're going to say sink, sink, sink together. And I'd like if you could also help, because we need as much brain power as we can get. And we'll see if it'll work, okay? Ready to give it a try? Okay, it's up here. Everybody.
Sing,
sing, sing. Come on, I can't hear you.
Sing, sing, sing.
Whoa! Okay. Wow, you guys are clever. How do you think we made it go down? Yes?
The elevation and the vibrate.
The elevation. Okay, maybe it's something else? Anybody want to try it? Who wants to try it? Okay. Now, remember, the key that we said, no stupid questions, no stupid answers, and we don't laugh at each other. We're a team. We're all trying to learn together. So why don't you, first of all, tell me, what is your name?
Kyle.
Kyle, okay. So Kyle, give him a big hand, because this isn't easy coming up and standing up in front. Now go ahead and let's see if you can tell us, what do we need to do?
Sing.
Okay. Everybody.
Sing.
Sing.
Sing. Sing. Sing. Sing. Sing.
You are thinking.
Sing. 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 Sing.
Okay, let's stop for a minute and think, maybe there's something else that made it go down. Tell you what we're going to, yes?
Like the vibration of sound?
Okay, I'll tell you what. Okay, let's see if it's going to work. Concentrate again, everybody. Let's go now. Sing. Sing. Whoa! Okay. Okay, so now, okay, what did you? Okay, what did you do? You squeeze the bottle. Okay, so you squeeze the bottle. So it isn't really brain power, okay, even though you do look very intelligent, but it is the pressure that we make. But while you squeeze the bottle, what made it go down? Anybody have any idea? Yes?
Pressure?
Pressure, yes, but we need to be a little bit more specific. What do you think would make this go down? Yes? The water level? Okay, the water level where? In the bottle, or the water level inside the diver? Give him a big hand, okay? Because you'll actually, now I'm going to put this one in. And we're going to be able to see what happens. You can stay here for a minute. And why did you also come up? You come up because I also see it. Now, as you increase the pressure, okay, look inside. What happens to it? Why don't you take and do it? Turn around. Okay, squeeze the bottle. But look inside that little diver, the clear one. What happens to the level of the water? So the level of the water goes up. Now, what does it do to the diver? Does it make it heavier? Okay, so it makes it heavier, and therefore it sinks down. Where's another word that we also use? What is it changing? It's changing the capacity, something else, starts with a D. Density, okay. What's happening is that the density of that little diver is comprised of whatever it's made of, but plus the water, whatever water's in there, whatever air, etc., right? Now, what's happening to the air that's inside the diver when you compress it when it goes down, what's happening to the air? It's going out. Okay, so it goes out, it sinks to the bottom. How does it go back up? How does the air go back in? Where does it's in water? Maybe something else is happening to the air. What do you think happens to air that we can put it in a smaller space? We can take air and we can put it in a smaller space. What is it called? Sort of like if we compressing. If we take and we actually compress air, okay, then we can take more air into that smaller space. Okay? So, to me, thank you very much. Give yourselves a big hand. Okay, so what we've seen is, we see the divers, okay, going down because we increased the weight. We've seen that we changed the density, increased the density, but we also learned that air is compressible. I'm going to be rushing through some of these things because we don't have that much time, okay? But I want to show you another little activity here. This is just a test tube, okay, just a regular test tube, and there's some water here. I'm going to put some water inside. And I have a disc. It's just a regular little flat disc, okay? I'm going to turn it over. Now, what do you think will happen when I let go of my finger? Yes.
The disc will stay on the tube.
The disc will stay on the tube. What's going to make it stay there? Okay. Well, let's see. Okay. Now, when a magician does a magic trick, what do you do? Yeah! Oh, you know, because we like hearing it. Anybody have any idea what's making it stay here? Yes? I'm squeezing it in. This time, I don't think so.
Isn't that glass like that?
Sorry?
Isn't it glass?
No, this is actually plastic. Okay? You wanted to say?
When it was upside up, you had like air still in it, and you put the thing on, and then you went like that, but the air just like sucks it all up in the air.
The air got trapped inside.
Okay, it might be. Now, I want you to think, have you heard of balanced and unbalanced forces? Have you learned about that? Okay, or equilibrium? Okay. Let's take a look at, we'll come back to that in a minute. Let's see, what do you think about this? This has holes in it, can you
The air's
see?
gonna pass through it.
Yeah.
Okay, and you think I can get this to hold the water up?
No.
Okay. This isn't easy, I'm telling you now.
Whoa! That was cool.
Okay.
The air things get in between the holes in the screen.
Okay, I want you to try and think, is it possible that maybe there is something, what's around us? What's here?
Air and
Oxygen and more. And what is it called?
Carbon dioxide.
Well, and carbon, and all of this is called air, right? Is this, the air here, is it a high pressure or a low pressure?
Hi.
High, okay. Who thinks that it's a high pressure? Who thinks it's a low pressure? And who isn't thinking? Okay. Let's see one more little thing. And to go back to the first stage. Now, watch carefully. How about
Whoa.
this?
Holy cow.
now that's messed up.
It's like a straw.
And it is like a straw, right? But what's holding it? When you do it with a straw,
You have to put your thumb.
what is holding it up?
Oh, the thing in top.
The thing on the top.
This is close,
air.
so it
Well,
holds it in.
Okay, so you know something, maybe. Well, one of the things we say science never sucks, okay? So the question is, maybe there is something that is pushing around, okay? Now, this is not easy to understand and not easy for us to figure out. So what I want to do, we're going to do a few activities, okay, that will help us understand, because we can't really feel the pressure here. It's called atmospheric pressure. And it is quite significant, but we don't really feel it. So the way that we can learn about it is by doing all sorts of activities that can show us and convince us that maybe there is quite a significant pressure. What I would like to do, is it possible for them, just because we're going to be doing something with water, to just put the books aside so that they don't get wet? Yeah. What happens to the dye, okay, that we put inside? What is slowly happening to it? Yes.
It's changing color.
It's changing color, and what is it moving around?
Spreading out. Yeah, it is.
Okay, why do you think it's sort of moving and spreading out? What's making it, what's inside the water? What do we have, what is the water made of? Little what? Molecules. Okay, now those molecules in the water, are they staying together or are they moving?
They're moving.
They're moving, okay. So the difference between a gas and a liquid and a solid is that in a gas we have the molecules moving around very fast and sort of knocking and banging into each other. In a liquid we have them moving slowly or slower, but they are still moving. And in a solid we have them what? In a solid, what happens to the molecules? They're staying together, but they're just vibrating, okay? So what we're seeing here is eventually, this is called dispersion of the dye, that eventually we'll see it going throughout, and it'll become equal. Okay, what you should do now is, first of all, let me take back the dye. Okay, thank you. Okay, thanks. Now what I'd like you to do is, you're going to take this, this little container, the plastic container. You're going to make sure that the valve or the tap at the bottom is like this. Okay, so it's closed. And you're going to pour water up to this here. And if you notice, the lid has holes in it. So once you've poured the water in, we will flip it over, but before we flip it over, I want you to talk about what do you think will happen when you flip it over. So go ahead and pour the water in. Why when you have hot water, does it actually separate all?
How much do we put in? Is that enough?
Yes, let's do it.
What happens?
Because they're moving.
Like that? You dive.
Okay, now, at the moment, what I want you to do is, watch me for a minute. Just you put this container underneath that hole. You're going to put this, in the meantime, just lay it like this. And I want you to talk amongst yourselves and discuss, what do you think will happen when you take that top bottle and flip it over? Talk for a minute. What do you think is going to happen? Just talk about it, think about it.
I can see you.
Okay. This table, what do you think is going to happen? It's going to stay in. Okay. What do you think is going to happen? Stay in.
It might fall into
It might and it might not.
It might and it might not is a very diplomatic way of saying things. And what do you think? It's going to stay in. Okay, why don't you all go ahead and turn it over and let's see what happens.
Hey, we got
Oh,
You have a different one?
That's cool.
I said it might and it might not. Hey, it's
So we got it right the other way?
No game.
I
told you it was there.
Dude, it's still
So, what's holding the water up? Which pressure is holding it up?
Because there's no air going through it to let the water leak.
So the pressure inside the bottle is holding the water from coming through the holes. Is there somebody think something else maybe? Could it be that, is it possible, just as, what's it called if I'm going to make sort of an educated guess? There's another word for it in a second. Hypothesis. I'm making a hypothesis, just maybe. The air around us here is holding the water. Is there anybody here that thinks that it's possible? Who thinks it might be possible? Who thinks that it can't be? Okay. Now, what do you think will happen if you go ahead and just open the valve here and put your finger on?
Oh, I thought you meant put your finger on.
It's like a shower, right. Now, what are you doing?
We're all having fun.
I have this bottle. I am pushing it. What's happening to it? It's moving, okay? Now I'm pushing again, but I'm pushing on the other side. What's happening? It's moving in opposite direction, right? What's happening now? I'm pushing very hard.
It's not moving.
Why isn't it moving? Oh, raise your hand. Why isn't it moving? Somebody, yes.
We're pushing on both sides.
Because I'm pushing on both sides, but more than that, I'm pushing together and equal. Okay, so what makes things move is whenever there is a difference. Okay, again, I'm going to make this hypothesis because I want you to start thinking about balanced and unbalanced forces. Okay, so now go ahead and do that shower thing again, but I want you to do it and stop somewhere in the middle. Okay, stop it and close it once it's sort of half out.
He said half off.
Okay, four more. Okay, when it's about half empty, I want you to stop for a minute.
Oh, half empty?
Yes. Go ahead.
When it's half empty, stuck.
Yeah, turn it over. Let's do the shower again. Sorry? Why are we getting? Oh, he's actually wants to see me doing this so he can then learn how to do that.
Try to go a little bit more.
Yeah.
Okay. Now the question that I want to ask you, okay, everybody close it and take your hands off. The question that I want to ask is, it isn't moving, right?
No.
Why? Raise your hand, okay? Why isn't the water moving? Why isn't it coming out? Yes?
Because it's closed and there's no fresh air going through.
Okay, I want you to talk, let's talk about, what am I speaking about? Balance and unbalanced forces. Why isn't it moving? What can we maybe start assuming? There's something that's pushing it down, right? And we have now blocked this. When we open it, we saw it going down. Now it's blocked. Couldn't we assume that whatever is pushing down, maybe there's some equal and opposite force that is pushing up? Possible?
Maybe, yes.
Maybe, okay. Because if you open it, now, let's see, everybody, you go ahead, watch what I'm doing now. I'm going to squeeze the bottle a little bit, and what happens to the water?
The water squirts out.
Water squirts out. Now watch what happens when I let go. 1, 2, 3.
Air goes in. Air goes out, air comes in.
So on one case, I was increasing the pressure on the bottle, and therefore we saw movement, water going down. When I let go, I decreased the pressure inside, and we actually saw air being pushed in, not sucked in, but being pushed in, okay? Now, again, since today we're rushing things a little bit quicker, we're going to all put this, let's put this all back over here. We're going to go to the next activity. Question. We have a sealed, you have a glove that is sealed, okay? Air can't get in, air can't get out. Do you believe, if you could give this to me for a minute, that with my magical powers, that I can make this glove grow inside the bottle?
Yeah.
Okay, everybody watch carefully. How can I do it? Move this? Okay. Is this working?
Shake it. Wait, no, close it.
Okay.
Shake it real hard.
Okay.
And then open it.
Okay. Magic power? Well, actually, I don't have any magical power, so we're going to need to use... Anybody have any idea how we might be able to do this? Yeah.
Take it out and blow it out.
Take it out and blow it out. Okay, that's one way. Is there a way of doing it without taking it out? Hmm?
Blow air in it. Go.
Open it. And then blow.
It is open.
Open it, close it, close it.
Okay. I'll tell you what, I'm going to give you something. Now remember that it is sealed. I've given each one of you a pump. Okay, if you operate this pump, if it'll make it grow. Do it quite big, do it quite hard, okay? And many times. Let's see. Now, I have a question. Okay, let's stop for a minute and let me ask you guys, okay? How do you think she made this glove grow? Okay, so she was actually taking air out. Did you feel that you were taking air out? Okay, so we took the air out. Did we take it out from the glove or did we take it out from the bottle? From the bottle. Just from the bottle, right? But what made... Is there any air in the glove now? No. No? Okay, you want to think about it? Coming back to... One of the things we need to realize, okay, our world, have you learned any laws? In science we have laws. Does anybody remember either a name of a scientist or a law? Yes.
All reaction has like an equal and opposite.
Okay, very good. And that is Newton. And which law? Do you remember which one? Third law. Actually, I can show you afterwards if I have time to show this thing. So that's one of the laws. Now, what does it mean that we have a law? What does it really mean that we have that law? What is that? Okay, laws actually describe the way that our natural world around us works. And what that means is that whenever we put in the same variables, okay, exactly the same, we will always get the same output, okay? So that makes it a law because it means that whenever we put this in, we will always get this out. Now, one of these sort of generalized laws is the of equilibrium, okay, and balance. So things aren't just happening. They follow quite strict laws because if not, then either there's something wrong in our experiment or we're entitled to get a Nobel Prize because we found something new. But as long as it's not, then we need to appreciate that it follows laws. So Newton came up with several laws, and Einstein has laws, and Ohm has laws, and Pascal has, and these are a lot of scientists that came up with patterns. That means whenever we do this, we will always get this. So we need to understand that our world things don't just happen, they follow these laws. So I want you to start thinking that this sort of rule of pressures or differences cause movement. Can anybody think or give me ideas, other examples of whenever we have a difference, something moves? As an example. For instance, what is the wind? How do we get wind?
Air moving
From
fast.
God.
Air moving. Okay, air moving from where to where? What? Okay, air moving from where to where? From high pressure
So low pressure.
to low pressure. Very good. Another example. What about electricity? What do we have in a battery?
Energy.
Yes, but what do we have? We have two sides.
Power.
We have a plus.
And a negative.
We have a plus and a negative. A plus and a minus, okay? Or positive and a negative. And as long as there is a difference between them and we close a circuit, will have a movement of electrons. What did you see before when you put the dye in? What did you see there? They were moving and they were dispersing until we would have equal concentration, equilibrium in the concentration. So this follows. Even have you heard money markets? You know, anybody listen sometimes to the business sort of sections, or you hear it where they say, you know, there's a high demand of the Dow Jones is going up and going down. All of those are because of market pressures. If somebody wants something very much and somebody wants to sell it, they'll exchange until they've reached that equilibrium. So I want you to go back and let's think about this. At this stage, is there any air in the glove?
No, there isn't.
Maybe a little bit. What if I told you, if we really think through it, let's say that there is zero air inside the glove, therefore zero pressure, and there is zero pressure on the outside, we still wouldn't see any movement, right? But maybe, because we see that something is making it grow, maybe there is some pressure, a little bit of air that's trapped inside. And what happens then? That air, when we close it, let's say that around us here is atmospheric pressure. It's a certain pressure. When I take that glove and I seal it, I've just sealed the air that's around us, which is at atmospheric pressure. So now, when I took the air out from the bottle, what was I doing to the pressure? Increasing it or decreasing? Who thinks I was increasing the pressure? Who thinks we were decreasing the pressure? And who isn't thinking? We still got a few of those. Yay! I know who was thinking. So we were actually decreasing the pressure. And we could see, and I want you to look again, one last time, I want you to do it. As you do it, and wait a minute. When you pull, watch what happens. You'll see that the glove grows and stops. Grows and stops. Grows and stops because it's reaching equilibrium, unbalanced. Balanced, unbalanced. Okay? Now let somebody else who hasn't done it do it. If you have somebody in your group, let them do it.
I think it's getting bad.
It's getting an eating problem doing that.
Is that what you
And you feel it was becoming harder?
Yes.
Why do you think it was becoming harder?
Because it's pulling and it doesn't want
I don't know, but it hurt my middle finger.
She uses that finger.
Yes, I do.
Why do you think it becomes
It
harder?
hurt.
Why do you think it becomes harder as you pull?
What is that?
You feel it became harder as you pull? Why do you think it becomes harder?
I thought he was mid-jump.
Maybe because what we're doing is just creating more and more
Yeah, you did know that club ain't got no air.
Oh
my God!
Like we're pulling a
No,
string.
you didn't.
So as we
Take
pull
my air out, watch.
harder and harder and harder,
Boy, challenge.
creating this larger difference.
Here, I will.
Actually, the opportunity we have to really feel
You will.
the atmospheric pressure. Okay.
And then you have a big head. Nice. You did that.
A lot of it is slowly seen because in a normal situation we wouldn't rush
Like
through.
always opens when she pulls it.
Watch that. Somebody hold that still. How'd you know that? Oh my God.
Let's stop for a minute, okay? We're going to do one last experiment.
Let me see that. It might be a little bit.
Okay.
It's gonna suck on you.
Each one you now have the jar with water. You have an empty glass jar. Please don't do anything that I don't tell you. And you have the pump. I want one person is going to operate the pump. You're going to connect it to the empty jar. The other one's going to hold the empty jar. And I want you to operate the pump 10 times and then close the valve halfway and wait. Okay? Okay, and then what you're going to do...
Listen, guys.
Okay, is everybody finished? Okay, now, what you're going to do is disconnect the pump from it, but leave the tube on, and we're going to put it inside with this, and you aren't going to do anything. Just put it in upside down with the tube in the water, and I want you to discuss what do you think will happen when you open the valve. Okay? Okay, go ahead and do it.
Oh, snap.
Oh, look at that.
Oh!
That's messed up.
Look, it's a key,
Yeah.
upward.
How did it get that far?
No! We're not going to class.
Reading sucks anyway.
Please stay here for a
So
second.
now, what's making the water go up? It's defying which pressure, inside or outside?
Inside.
Stop so much. Rubbing it covers up all those good spots.
Okay, was the pressure inside greater than the outside or lower? What did you do? So if it's greater, wouldn't we see bubbles?
You'd think.
You'd think, well, okay, what did you do? Again, I want you to raise your hand. What did you do? Did you put air in to the top, to the bottle at the top, or did you take air out?
Take it out.
You took air out. So if we took air out, did we create a higher pressure or a lower pressure? We created a lower pressure. Lower than what?
Density.
Lower than which pressure?
Higher pressure.
Maybe, again, we're coming back all the time to this pressure around us here, that air pressure, okay, that maybe, again, we've seen three things. What have we seen already? We saw the shower, and we saw that something was holding the water up. We saw the glove, and we saw that something inside would make it grow. Now we're seeing something that made the water go up against gravity, sort of defying gravity. Now, why did it stop?
It ran out of air.
Because it ran out of air is one explanation, but coming back again to that concept that I'm trying to convey, what did it reach? Equilibrium. Okay, so it stops now because it reached equilibrium, because whatever it is, most probably that is pushing, that would, you know, what is pulling the water down? Gravity. So gravity pulls water and everything down. By the way, does gravity also pull the air down?
No.
Does air take up space?
Yes.
Does it have weight? Air?
No.
It has no air? Why wouldn't it have weight? Yes, you can go like that, but is it a substance? Is air made up of something? Of molecules, okay, so it's made up of something, most probably, okay, it does also have a weight or mass, okay. Now, I want to ask you a question. How high did it go here? About 350, right? How much do you have? How much did it go up? 300, okay. Let me ask you a question. We're going to have a little competition. The competition is going to be who could make, we're going to start this again. I want you to see who can make theirs go up the highest. So take it out. Just let me show you for a minute.
Yeah.
Okay, all that you do is you just open it like this.
I'll do it like 10 seconds.
Open up. Take it on the side. Okay. Pour it. And then put it back.
Excuse you?
I'll make ours get more.
Put that thing first. This.
We're tired.
We're tardy, and nobody's in our lady class.
We have to learn the highest.
Yeah. I have my classes in 10 on him. All my classes are done.
Right.
Okay, once you've done it, I want you to whatever you do to make it go up, but you're going to have one try, and we're going to make it go up, and then you leave it then, we'll see who's made theirs.
Do we do it right now?
Yeah, just go ahead and then leave it like that. Now, what do you think?
It's still up there.
What do you think you need to do to make it go up higher? What do we need to do to make it go up higher? If we did,
Get over.
Yours is up higher than it was the first time.
Yeah, it is. Yeah, we're gonna try it again right now.
Ours isn't stop! Ours isn't gonna stop! Ours isn't gonna stop! Ours isn't gonna stop!
How hard is yours go?
Well, look at it go down on the other one.
actually, when you
Yeah, more than us. A lot more than us.
So let's see. So
These guys down here did 400. Right here.
well, these guys got even more.
Yeah, they
Okay,
got like
almost 450. Okay, so let's give this guy now.
Good job.
So what did you do to make it go up higher?
I kept on pushing it and then more protect.
Okay, so by pumping it more times, more than 10
Can we
times,
do it again?
we created a larger difference which made it go up higher. Why did it stop now?
Because it doesn't ran it.
Why does it stop now? Why did all of yours stop? Come on, I want you to show me that
We
you've
didn't
caught on
pump it as
something.
much.
No, why isn't it moving now?
Because there's no air there.
doesn't feel like it.
It all went.
Why? What is that concept we've been talking about all the time? Why did it stop?
Gravity.
Because it reached equilibrium again. Every time it'll stop the minute that the forces pushing down and whatever forces are pushing up are the same.
Then go.
Not exactly. What do you think? Yes. It measures the amount actually of current. Okay, who knows what is current? Yes. A flow of electricity. Okay, so it's the measurement of how much electricity is flowing. And I'm going to use this to measure and to make a connection. And this will show us how much. Now, I now have energy that's coming here. So let's first see if anything happens when I connect it over here. Is this moving?
No.
No. Okay. Now let's see what happens when I switch on the sun. Does it move a little bit?
Yeah.
Okay. And look what's happening here. Can anybody see? You see the little light bulb, okay, lights on, and we can see if I disconnect this, okay, so it isn't lighting on, and if I switch off this light, so does the light here. So we can see that the energy from the sun, okay, would come onto a solar panel, and what does the solar panel do? Just raise your hand. Yes? Sorry? Collects the energy. It's collecting energy and changing it to something. What is it changing it to? Yes? To electricity, okay? So it's collecting the energy of light, okay, and it's converting it into electricity. And then from electricity, we can see how we can power certain things. So we've seen that we can turn it into a light. And let's see what happens here. What is this? It's a little motor. And in the meantime, you can also see what happens to the current here. Now let's see what happens when I move it back. Why is it going down?
Because the power's
Okay, because there is less that is coming, less of the energy, okay, or the light that is reaching there. If I move it closer, it's hope it doesn't fly off the motor. Now, we could also convert it into Is it changing?
Yeah.
Okay, so it's changing the pitch a little bit. And what is the last thing that we have here? A battery. Now, this is a rechargeable battery. So actually, if I put it in here, it's now charging. So this is a way that we can take energy that's coming from the sun and we can store it for future use. Okay, when will we need to use that energy from the sun? Sorry? When the sun burns out, but, well, even before that.
When the sun sets.
When the sun sets, okay? So when we don't have sun, we don't have any energy from that. Well, if we have stored that energy somewhere, okay, then we can use it at night, okay? Now, we could actually see, you could sort of say, well, we don't believe you that that can really work. So if I switch this off, and I don't know how much I have managed to charge it, but let's see what happens now. Now you see this isn't on, right? So what is making the buzz now? How can we prove it?
Because it's
Raise your hand, yes?
Because it's hooked to the battery.
Because?
The one end of the line is hooked to the battery.
Okay, so number one, we could trace it. We could also take it out. We see it isn't working. And when I put the battery in, okay, and now it works. And this turns. And this lights. Okay? There are a series of activities with this, okay, where you go through and you measure various things. I just sort of, again, rushed through this, but the whole idea is to show us how we can take a clean source of energy, right, no pollution, and how we can convert it so that we can use it in our daily life, okay, so that we could make it power all of these things that are here, okay, and we could use it, and we could see how we can take that same energy and we convert it from one form to the other form.